Right, do you have the diagram there for 12? Have a look at it. Do you have this? Where's your one? Where is this? Because you knew I was going to use this today, yeah?
Yeah.
So where's your one? That is terrible. You're late and you forgot this. Can you see the diagram there?
Yeah.
You see it? Yep. Yep. So what's happening here is that a box is being pushed up a rough horizontal slope at constant velocity by a force of 80 newtons, and the slope makes an angle 15. Part A. So we just think for a moment. I'm pushing this up. Listen. I'm pushing this up a slope. So what type of work am I doing? Or what is being achieved? Potential, very good. Because it's being lifted off the ground. So the amount of work that I do will be how much... No, yes, okay. It's how much, it's not quite potential, that's actually part B. If you read part A carefully, it's how much work your body does, so to speak. So you push something with a force, and you push it for a distance of 5 meters. So do you remember the formula to work out the force, the work? Do you remember it? Work equals distance. Yeah. Force multiplied distance is the work. So you push at 80 for 5 meters, and that'll be 400 joules. So that's how much work you do. And then AMRO, as you were saying, the second part is the gain in potential energy. So what's the formula for potential energy? mgh. Now the m is 20, the g 9.81. Now look. They don't give you the height, so you have to use your trigonometry maths lessons to work out the height, because you know the hypotenuse and you know the angle, so you can work out this side here. Okay, so actually it'll turn out to be 5 sine 15. Now, you push this box. How much energy did you use pushing the box in your body? Not 40. 400 joules. How much energy did the box gain from being lifted? 253.9 joules. So some energy was lost between you pushing it and the box being raised, and that is friction. Yes? Why did you miss the first class?
I must click the phone, the alarm.
No.
It is like a simple excuse, but it's really
You
happening.
had like an hour to think of an excuse. I don't care if it's the truth. Like, I want a better excuse than that. Go, sit over there. Come around this way. Don't fall over that. Or you can sit here if you can see. Yeah? Alright, okay. I lost my train of thought. So as I was saying, you push with force of 400. The box only gains 253. So the difference was lost with heat and friction. So part C is you lost, let's see, 400 minus 253.9, Now that's not quite finished. There was this much lost in friction.
How did you find this?
Which one? This number?
Yeah.
That minus that.
Okay, no.
Yeah, the lost work. But he does not ask you how much energy was lost. He asks you how much is the friction force. So what formula do you have that relates force and work? Well, the one that we have at the start. Force equals work, no, sorry. Work equals force by distance. So force would equal the work divided by the distance. Okay? So the friction force would equal the work that the friction destroyed divided by the distance it was applied. So here it'd be 146.1 over 5. .2 newtons. There is a second way to do this. It's actually more complicated and longer, but it'll give you the same answer. Do you know which way it is?
Should equal the energy gain plus energy.
No, not with energy. Something else.
The angle.
Efficiency?
No.
The angle.
No.
Work minus friction. The angle.
No, stop saying work for no. Alright, I'll just show you. I'll go back to this, but I'll slide to the left for the moment. A second way to do this problem, but it's much more complicated, is you take the weight,
The angle.
yes, and you break the weight up into two parts, and then there's another force here. So there's friction, and then there's the weight in this direction, and these two should match, should match this 80 here. So you'd end up saying 80 equals friction plus Wx. So friction would be equal 80 minus Wx. And then this angle here would be 15. So this one here would be W cos 15. So that one there would be W sine 15. So you'd get 80 minus W sine 15. So you get 80 minus 20 times 9.81 times sine 15. And if I type that in, I should hopefully get the same answer. And what did I get previously?
29.2.
And here I got 29.2 as well. But I think this is more complicated and longer and easier to make a mistake, whereas this way is just much more straightforward and to the point.
So we can use scale and vectors to find out the friction by
Yep.
minus.
So you can use scalars and vectors and trigonometry, or you can just actually use your work equals force times distance formula. Yeah, both's fine.
So I wonder also, because ms unit meter second is what? What is the unit? Like watt or is there any like
Unit for what?
ms
MS?
meter second?
Meter seconds?
Is a watt or
Meter seconds is force by time, which I think is impulse. No, sorry. No, Andy, I've said the wrong thing. MS is distance by time. Is distance by time anything?
I have no idea. I just get the behind question is there, so I just ask him. Like, seen it before, but I don't know what's there.
I don't know. If it comes up, I'll do it. Alright, I'll stop this one. Next one then.